Okay, so ExamCraft 2017, Even Cert Higher Level Math, Paper 1, Question 6, differentiate y is equal to x squared sine of 3x plus 5 with respect to x. Okay, so remember this is going to be the product rule because it's two terms being multiplied together. So our u from our log tables, our u is going to be the first, v is second, then it's u dv dx plus v du dx. So u is going to be x squared. V is equal to sine 3x plus 5. Our du dx is 2x to the power of 1, or just 2x. So bring down the power, reduce the power by 1. Now, for those of you who are not in my class, I really like differentiating trigonometric functions or equations here by following the steps of differentiate the angle. Now the angle is always the thing that comes after the sine or the cos or the tan. Then differentiate the trig. So that's the sine, cos or tan, and then leave angle alone. As in write out the angle alone. So again, differentiate the angle. You're just going to get 3x. Differentiate sine. Log tables, sine goes to cos. It's cos. And then repeat the angle, so it's 3x plus 5. And then we're going to go dy dx is equal to u dv dx plus v du dx. Dy dx is equal to x squared dv dx, which is 3x cos 3x plus 5 plus v, which is sine 3x plus 5. And I'm going to put a square bracket around that because when I'm multiplying it by the 2x does not get multiplied in here. It gets multiplied by the whole thing. So when I simplify this out, I'm getting dy dx, I need a smaller pen because my writing is horrible, is 3x by x squared is 3x to the 3. Cos 3x plus 5 plus, and I said this 2 needs to go all the way out to the front, 2x sine 3x plus 5, and you leave it like that. Okay, part B, differentiate. So y is equal to cos inverse. Okay, so it's an inverse. Now this looks weird. Remember from page 21 of your log tables, and I'm actually going to go to page 21, I'm on 25 there, so page 21 of your log tables. If you have a negative power, it means that it was just on the bottom line of a fraction. So this x to the power of 2, I could make that x to the power of minus 2, and it makes life an awful lot easier. Okay, so it's the integrating now a cos inverse. Cos inverse, cos inverse, cos inverse, cos inverse. Okay, brilliant. Cos inverse is here. I always treat this a as a 1. Now this only works if it's an x, so there's a rule that we need to know as well what to do when you've differentiating a cos inverse like this. It should also have written in here multiplied by the derivative of the top line. Okay, so what we have is y is equal to cos inverse 2x to the minus 2 over 1. So we're going to apply the rule from the log tables. So it's minus 1 over dy dx minus 1 over the square root of the bottom line. So this was 1, a squared, square root of 1 squared minus the x, which was on the top line, squared. So minus 2x to the minus 2 squared. And it should always be by the differentiation of the top line. So the differentiation of the 2x to the minus 2, which would give you minus 4x to the minus 3. Tidy that up a little bit. Dy dx is equal to minus 1 all over 1 minus 4x to the minus 4. Now to explain where that's coming from, it's 2 by 2, which gives you the 4, and it's x to the minus 2 by x to the minus 2, which will give you x to the minus 4, multiplied by minus 4x to the minus 3. And you could treat that as being over 1. And now look, it's a fraction by a fraction. How do we multiply fractions? Top by top, bottom by bottom. So we could just say it's dy dx is equal to 4x to the minus 3 all over 1 minus 4x to the minus 4. I'd probably leave it like that. I mean, they're not going to ask you to really go any further, but you could, with that that x to the minus 3 on the top line, you could leave the 4 on the top line, x to the 3, because now it's on the bottom line, so it's x to the plus 3, square root 1 minus 4 x to the minus 4, and even that you could write as fraction, but that's where it gets a little bit strange, I suppose. As a question goes, I don't particularly like this question, but I really like the next question. I think it tests an awful lot. It tells you what y is. Okay, we know that's y, and they want us to show that all of this is true, and that's y as well. So I need to find dy dx. So dy dx, and it's going to be another product rule because it's two terms being multiplied together. So our u is equal to x to the 4, our du dx, 4x to the 3. Our v is equal to e to the 3x, and our dv dx is equal to. And how to differentiate these, I would say, is bring down the diff of the power and then leave everything alone. And what I mean by leave everything alone, as you might have noticed in the previous one, is to, or in the first question, part A of this question, is to just write it all out again. So the differentiation of the power here would just be 3, and then leave everything alone means write it all out again. And now we're going u, which is x to the power of 4, by dv, which is 3e to the 3x, plus v, which is e to the 3x, by du, which is 4x cubed. Okay, so now I know that this is all of this. Filling all of that in, then I just need to show that this is true. So it's 3e to the 3x. Now, this is the green bit that I'm writing out, but I'm just going to reorder it as I'm writing it. You notice that this is this bit right here. I just brought the 3 out to the front. Plus 4x cubed e to the 3x. That's this bit. Minus 3 by y. X to the power of 4 e to the 3x is equal to 4y, which is 4 x to the power of 4 e to the 3x over x. And let's start multiplying it out then. So it's 3x to the 4 e to the 3x, nothing I can do there, plus 4x to the 3 e to the 3x, nothing I can do there, minus 3x to the 4 e to the 3x, that's interesting, 4x to the 3 e to the 3x. And what simplification has happened? This is cancelled there to leave us a 3. And I've just multiplied this in here. You might notice now that this cancels with this. 4x to the 3 e to the 3x is equal to 4x to the 3 e to the 3x, and that is the question done. QED, done. Let's look at the marking scheme. Nice little 5-mark question to begin with. You couldn't really hope for much more than that. Just using the product rule straight away. This is a little bit harder, to be honest. That is kind of hard. I wouldn't expect many people, but a lot of people will forget that. They will get this bit, but will forget to multiply by the differentiation of the the top line there. And here, I think like that's a great 10-mark question. Really, really great. I think you should be very happy if that ever comes up.